Now, good morning, everybody, to our 38th webinar in the Urbia series, and it'll be our final webinar for 2022. So this morning, we are going to have a look at the Danish biogas industry as a model for Ireland. A couple of weeks ago, on the back of the agrofossil-free project, which Biogas, our partner, I visited Denmark, and we met a number of quite interesting industry representatives over there. But one of those is our guest speaker today, Bruno Sander Nielsen, and he outlined where the Danish biogas industry has advanced over the last number of years. Now, for those of us in the industry for many years, we'll always recall that back in the 1990s, Denmark was really the place to go for biogas. They had developed the technology. They developed a model that we were very strongly looking at here in Ireland, and there was a lot of collaboration back in those days. And they were generally seen as the industry leaders across Europe. In recent times, from 2000 on, we've seen a huge expansion in Germany, and eyes started to turn to that direction. But what's quite interesting is how the Danish model has advanced over the years, and in particular over the past 7 or 8 years, they've seen dramatic increases in production of gas and in the use of the technology. And it works a lot closer to their agricultural system. So for a country like Ireland to look at Denmark as an example, it gives us some very interesting insights into how we could develop our own industry here. They have a similar sized country, relatively similar climate, relatively similar agricultural base and population size. So to see how they have advanced the technology and used it as a mainstay within their environmental model as well as their energy model, it's definitely something we can learn a lot from here in Ireland. So it is something that's why we're very interested in how they have advanced it over the years. So just very briefly, you will be familiar with the Irish Biogas Association, most of our viewers at this stage, but we are established in 1999, and we do represent the industry on Ireland, where we look at biomass, biogas, biofuels, biochar, and all wood fuels and energy crops. So we work to represent our industry. We work to run several information events throughout the year and to inform policymakers, as well as offering supports for our membership as well. So you can find out a lot more on our website, urbia.org, to see our overall team and what we do. As I said, this is our 38th webinar. If you wish to go back on any of the other 37, they're all recorded. They're all on our YouTube channel. So you can go back at any stage to reference those. The full list is there. And we cover a wide range of areas, from liquid biofuels to solid wood fuels and to biogas, as well as our most recent one, which is in sustainable aviation fuel. So if you wish to go back and have a look at the whole series or parts of the series that are of interest to you, it's all there in the YouTube library. Today, our guest speaker is Bruno Sander Nielsen. Bruno, who I met on that tour 2 weeks ago, definitely impressed me with the slides he was showing and in his knowledge of the industry and showing how the Danish industry has advanced. So I think you'll find today's webinar very interesting. Bruno is employed at the Danish Agriculture and Foods Council since 1990. He has worked for the Danish Biogas Association for 25 years, and he's currently their Chief Operations Officer. He's also the Chief Advisor for Danish Agricultural and Food Council, DAFC. Apologies. So we'll start off with Bruno. If you want to come on screen there, we'll have a Q&A session afterwards with Barry Caslan, Renewable Energy Specialist with Biogas, and Sean Finan, the Urbia CEO. We will also have, throughout this, there'll be Q&A session for any of our attendees. So if you do want to ask any questions as they come to mind, please put them in the Q&A session. You don't have to remember them, just put them in straight away, and we will get to them towards the end of after the presentation and both during and after the panel discussion. So Bruno, if I can ask you you're on screen already, I see. Just get you to unmute there, please.
Yes, thank you. So you asked me to share the screen? Yeah.
If you could, please, yes, if you could. Many thanks for joining us this morning.
Yes. Share. Can you see it now?
Yes, I can.
Yes, thank you. Thank you.
I'll leave it to you.
Yes, thank you. Thank you for the opportunity to talk about the Danish biogas sector. It's, of course, one of my favorite topics. I've been working in the Danish Biogas Association since before it was actually established back in 1997. And of course, we are talking about the renewable gas, but we are certainly also talking about the circular economy. Oh, I guess it's the wrong screen I have shared because I cannot.
Sorry, we could see the front slide, I think.
Yes. I have to delete one of them and try once more.
Okay.
Is it on now?
We can see the working screen from PowerPoint.
Yes, and it's in progress. Yes. And now I can shift the slides.
Yes, yes. We have it perfect there now. Thank you.
Yep. Yeah, thank you. You can see the Danish Biogas Association. We are the organization for all the stakeholders in the biogas sector in Denmark. Our members are, of course, the biogas producers, but also the industries and the energy sector that use the biogas. We are having the suppliers of biomass and the users of the digestate use it as a fertilizer. And we are having the technology and equipment suppliers, both those delivering turnkey biogas plants, but also delivering, upgrading plants, pumps and pipes and so on. In total, we have approximately 200 members. 70 of those are biogas producers, and they are producing more than 90% of the Danish biogas. And of course, our mission is to promote the production and the use of biogas. And we also promote the circular economy and the sustainable agricultural production. We are spending a lot of work also in the knowledge sharing, especially among the biogas plants, having regular meetings for the owners but also the managers on the biogas plants. If we look into the Danish biogas development the last 25 years, you can see on the left-hand side the biogas production in petajoules. It used to be very small, and within the last 8 or 9 years, it has increased rapidly. And you can see the whole increase is in the agricultural-based biogas plants, where we co-digest livestock manure and organic residues from household industry and agriculture. On the right-hand side, you can see the relative origin of the biogas through the 25 years. And you can see 25 years ago, 60% of the biogas actually came from wastewater treatment plants and from landfills, and only 40% from the agricultural-based biogas plants. But right now, it's more than 95% that is this co-digestion on the agricultural plants. So we have had quite a change in the Danish sector, but I guess it's a good way to look into bigger opportunities that we could have from the landfills and from the wastewater treatment plants. Right now, 30% of the livestock manure in Denmark is being digested. We are having a huge livestock production in Denmark, so we are talking millions of tons. And right now, more than 35% of the gas consumption is actually being biogas through the gas grid. So the Danish biogas model is very simple. That we take the livestock manure, either liquid slurry or deep litter, mix that with the organic residues from the different sectors. And here I always stress that the biogas plants, they are mainly a fertilizer factory, because we take the livestock manure, turn that into a better fertilizer, and we take all the nutrients in the residues and recirculate and reuse them as a fertilizer in agriculture. And of course, we could also take in the organic catch crops, the clover grass grown on the organic farms there, the nitrogen factories they are using in general. But if they don't have any ruminants to grass on the clover grass, then they cannot utilize their biomasses, and then they look very much into the biogas plants to turn that into a green livestock manure, we could call it. And then we have the byproduct from the biogas plants, the biogas, the biomethane. And we are talking a lot about the role of the biogas in the Danish energy sector. In Denmark, we have a rapid increase in renewable energy. Most people believe that renewable energy is from windmills and solar panels, and that the future is electrified. And of course, electricity will be very, very important in the future. But we also have to realize that if the wind don't blow and the sun doesn't shine, then we need to have some backup to deliver the electricity into the grid. And here the biogas is the cheapest and the best way. We are also having the challenge that the electrification does not meet the need in all the sectors. There are some sectors that cannot be electrified in a foreseen future. In the energy intensive industry, demanding high degrees of heat, but also in the heavy duty transportation sector. So we are filling the gap in the green transition where electricity do not meet the need. And we do that with turning the residues from agriculture, industry and households into a sustainable fertilizer with reduced climate and environmental footprint, and in this way coupling the circular economy with food production and the energy sector. If we look into the biomass input to the biogas plants, you can see on the left-hand side, it's in tons. 75% of what goes into the biogas plants is livestock manure, and it makes up 1/3 of the produced biogas roughly. Organic waste from industry and food waste is 15 or 20% of the input, and 1/3 of the biogas. We only use a small share of energy crops. The energy crops we are using is mainly maize. It's less than 5% of the input, and it's roughly 10% of the produced biogas. In Denmark, it will not be allowed to use maize as a feedstock in biogas from 2025. And in general, the politicians want us to reduce the use of energy crops. But this also means that we are basically utilizing the residues rather than the crops we can grow on farmland. If we look into the developments in the different biomasses the recent years, then you can see the increase in the biogas production is the green line, and the year 2015 is index 100. And you can see actually the biogas production has increased more rapidly than the increase in the use of livestock manure or the liquid slurry. And of course, that's because we are shifting towards other biomasses with a higher biogas potential from the deep litter, and of course from the energy crops, but mainly straw from the cereal production. That has gone up from 15,000 tons 7 years ago to almost 200,000 tons the last year. So this is increasing quite rapidly, and of course this has an impact on the biogas production, but also on how the digestate looks. What is the potential in biogas production in Denmark? The University of Southern Denmark made a report for the Danish Energy Agency a couple of years ago, and you can see they have calculated that the total potential in the future is more or less 90 petajoules of biomethane. 20 of that is liquid slurry. We have the deep litter, we have the organic residues from industry and from households, and of course some residues from agriculture that might be feed that's left over from one year to another. But you can see that straw is the main resource, making up almost 50% of the potential. And the bars simply shows one way of looking into the development into the future, how we need to install more biogas plants. And some of the straw is right now used for incineration in power plants, and that will be phased out. And this means that the straw will be available for the biogas plants somewhere in the future. So what's the expectations in the Energy Agency on the future situation in the gas supply? You can see the natural gas consumption is expected to decrease, and the biogas production is expected to increase in the coming years. And 1 year ago, they expected that we would be close to 100% supply of biogas by 2035. With the current situation in Ukraine and the Russian aggression, there's a tendency to phase out the consumption of natural gas more rapidly. We could also speed up the biogas production, and this means that we could actually be 100% supplied by renewable biomethane in the Danish gas consumption by the end of 2027. So what has driven the development? If we go back to the 2012, then we got a new energy agreement where the feed-in tariffs for the production of electricity was improved. We got a new subsidy scheme, a feed-in premium for the biomethane injected into the gas grid, and then 3 new minor feed-in support schemes for use of biogas in industry and for transportation fuel and for heat production. But simply to go to the conclusion, the main issue that has driven the development is that we got this feed-in tariff for the biomethane into the grid. And here you can see the level of the support. We had the basic level, 10.7 euros per gigajoules for electricity production, and that was increased to 15.5 euros, and based on 2 new subsidies, one with 3.5 euros, and this is being regulated with the natural gas prices. When the gas prices goes up, the subsidy will go down, and the opposite. And then there was a temporary support that was phased out by 2020. And then you can see also the level of the new support schemes. And here you can see the reason why the 3 minor support schemes are not used that much, simply because there's a better economy in the power and the biomethane sectors. So what we have seen is that until 2030, all the biogas was used in the local CHP plants and the heat used in the district heating. And the whole increase in the biogas production has been in the upgraded biomethane injected into the gas grid. And actually, this is not totally true, because there has been an increase in the production of biogas, mainly to industry, where they use the biogas to produce electricity and process heat. And at the same time, a number of the older electricity producing biogas plants has shifted to upgrading. So, but we have this rapid switch from 0% being injected into the gas grid 7 years ago, and this year it will be more than 80%. And this is very important, because now we produce a storable renewable energy, and that's what we are teasing our electrical colleagues with, that they need some additional things to store the electricity, but we can store it directly into the gas grid. And this means that actually right now the carbon footprint of the gas grid, or the gas in the grid, is lower than the carbon footprint from the electricity from the electricity grid. These numbers are in looking back, what's 12 months backwards for every month, and you can see we used to be at the same level during the summertime, but right now we are the greenest renewable energy in Denmark, and we can store huge amounts of volumes of gas in the Danish gas grid. But this shift from the use in the local district heating plants and the local CHP plant, and instead injecting the gas into the gas grid means that now we are having a commodity. And of course, here we have a market model for the biomethane that has been working for now close to 8 years. Of course, the molecules will go directly from a biogas producer from the injection point to the closest consumer. But in addition to that, on the free market, the energy value can be sold to any customer. But what happens when the biogas is put into the gas grid is that it is turned into gas, natural gas, or at least gas in the grid. It's not biogas. So if a consumer wants to have a green choice, then he has to buy the guarantees of origin that is issued by the Danish authorities with the rules in the European Renewable Energy Directive. So now we can sell the energy on the market, on the free market, and we can at the same time have an income from the green value. And actually, if you look into the biogas where it's being sold, or the biomethane, then you can see that almost 80% of the Danish biomethane is actually being exported, or at least the guarantees of origin are being bought by industries or transportation companies or municipalities in other countries. But right now we are having a shift in the framework conditions. We used to have the feed-in tariffs. You remember the 5 support schemes. Originally, that was without limits, both in the volume of biogas you could produce, but also in the time scale where you could receive the subsidies. Back in 2018, the government came to the conclusion that perhaps this was, at least it was favorable, let's say it like this. So they wanted to have an end to the support scheme, but they did it in a very gentle way, saying that new plants cannot enter into this framework condition, but those that already have made the investments, they will be guaranteed the support for a certain volume of biogas for a fixed number of years, up to 20 years. And therefore, we now know that we can produce 42 petajoules biogas within this support scheme. But they didn't want to close or to end the biogas development, but they simply wanted to have a new system based on auction and tenders. And actually, in a climate agreement from 2020, they decided to have a new tender system for the coming years up to 2030. Again, it's only for biomethane and electromethane injected into the gas grid. Those that get the grants, they will be guaranteed the subsidy for 20 years. And we can expect to produce 10 petajoules within this support scheme. But just to wrap up the framework conditions, it's very important to realize that we have been working with a lot of policies during the 25 years. In the agricultural policy, we had an agreement in the parliament in 2009, where we got the investment grants for the installation of new biogas plants. And we also, or the parliament decided to have a target that by 2020, 50% of the livestock manure should be digested in biogas plants. We didn't meet that, but we are at 30% right now, so we are close to the target. In the energy policy, I have gone through that. Of course, that's the feed-in tariffs, and the market is what is fueling the development, because they make it bankable. And then we have the circular economy. We normally say that we have the world record in incinerating all kinds of waste in Denmark, both from households and from industry. Back in 2013, the Ministry of Environment wanted to have a shift so that we should stop incinerating the organic fraction. For 20 years, it has not been allowed to put organic waste into landfills, but now they simply wanted the organic fractions to go from incineration and into the biogas plants, so that we could still harvest the energy potential, but at the same time we could recirculate and reuse the nutrients as a fertilizer. And the most recent thing is that climate is the number one political issue. At least it was until the war in Ukraine. Back in 2019, we had an election for the parliament, and this is called the climate election. And right after the government came into office, they adopted a climate law saying that by 2030, we in Denmark have to reduce the emission of greenhouse gases with 70%. And what the government did, that they established a number of climate partnerships in different industrial sectors, one for agriculture, one for aviation, one for shipping, one for energy intensive industry. And those partnerships had to draw up their own plans of how they would reach the 70% target. And what we saw was that biogas actually came in as a solution in 10 of the 14 partnerships. So suddenly we were in a situation where we used to be the guys that talked about we should promote the production of and use of biogas, and then it suddenly shifted to the users of the biogas. They wanted us promoted, and also agriculture wanted to have an increased biogas production to solve the challenges in agriculture. These figures are more or less the same as I showed early on. The use of biogas, the direct use off grid in the local CHP plants, the use in the heating in the individual households, in the power and heat sectors, and a larger part in the in industry. And you can see the decline that the Energy Agency expected 12 months ago, and here you can see the increasing biogas production. And this is the new projection we have made after the war in Ukraine, where we expect a more rapid phasing out, especially in the households, but also in a little bit in industry. And this means that we could meet the 100% supply in 2027. And then with a decreasing natural gas consumption, somebody could conclude that we would only need to produce less biogas. But of course, this is not the case, because we still have a lot of organic residues we simply need to handle somehow, and the biogas plants are the best solution here. But at the same time, we also could start to export the biogas to other countries, and it could be used in the transportation sector. So what's the expected feedstock in the future for this biogas production? We have made the projections, and on the right-hand side, again, you can see in tons. Livestock manure is the main input, still 1/3 or 40% of the biogas produced. We don't expect to be able to find more residues from industry. We can hope to have a constant level. You can see the energy crops will be phased out. And then we have a straw that will be the most important. It could also be grass from, we are talking a lot about that we should produce more of the protein for the feed, that should be produced from grass in Denmark in biorefineries. And here we will have a lot of residues that could go into the biogas plants. So we could have a self-supply in protein for the pigs instead of importing a lot of soybeans. So this is the feedstock, and of course this has an impact on the value of the biogas plants in terms of environmental footprint and climate footprint from the different sectors. But we expect that in the coming years we might end up that we digest or utilize 2/3 of the livestock manure in the biogas plants and 1/3 of the straw. And here we have to remember that when we produce biogas from livestock manure, then we are having a double positive climate impact. We reduce the emission of methane from the storage of the livestock manure, because we simply put into the digesters and collect the methane. and then afterwards the methane can substitute fossil fuels, and then we reduce the CO2 emissions from the energy sector. And here we have projected how much we can reduce the emission of greenhouse gases, both methane and CO2, from the agriculture and in total. And the black line shows when we consider that we are also having a energy consumption on the biogas plants, and there might be a minor slip of methane from the biogas plants. So the net reduction will be at this level, so that we can actually reduce with close to 5 million tons of CO2 equivalents in agriculture in 2030, and of this 1 million tons is reduced in agriculture. But the effect in agriculture depends on how we get the slurry from the farms. And this slide shows the importance of getting the slurry as young as possible from the stables. The red bar here is the emission of greenhouse gases, methane, from the slurry if there's no biogas plants, and the blue dot is the net emission. If we get slurry as we used to get it, where it could be 3 or 4 weeks old from the stables, then of course we will still reduce the methane emission from here to this level, and is indicated with the light green down here, and the black green is the substitution of the fossil fuels. But you can see simply by introducing the biogas, then we will reduce the carbon footprint from the pig production. If we could get the slurry when it's at maximum 1 week old, then we could actually get a level where when we only look on the livestock manure, we'll have a climate neutral production. And if we could get the slurry on a daily basis with line wrench systems, then we could actually get into a negative impact. And of course, that's the same situation in the cattle sector, although it's less important to get the slurry at that young age. We are also handling a lot of phosphorus, of course, mainly in the livestock manure that would be recirculated anyway, but also in all the other residues we use. It's a bit difficult to see in the left-hand side slide. So at the right-hand side, I have not the phosphorus in the manure part, but you can see we are recirculating up to 7,000 tons of phosphorus from food waste, from industrial waste, and so on. And to give an impression of whether this is important, I can tell you that the Danish farmers buy phosphorus in chemical fertilizers up to 13,000 tons. So actually what we recirculate is 50% of the use of chemical fertilizers. And of course, this is being very important as phosphorus is a scarce resource. And of course, with the very high natural gas prices we have seen the last year, then it also has a very high impact for the farmers' economy, that they can use the digestate instead of buying chemical fertilizers. Where are the biogas plants in Denmark? You can see the green ones, the agricultural plants, is mainly in the western part of Denmark. It's because it's here we are having the livestock production, so it's most feasible to build the biogas plants. And here you can see a number of different, a farm-scale biogas plant up north, a smaller centralized biogas plants here in the eastern part of Denmark, a very big cooperatively owned biogas plant in the south, owned by 60 farmers. It has been in operation for more than 30 years, and a rather new biogas plant up here, owned by investors. So when we look into the ownership of the biogas plants right now, we used to have most of the biogas plants owned by the farmers in cooperatives, but you can see actually we only have 5 of those right now. Utilities of municipalities were also the main drivers in the first years, 30 years ago, but now they are only in a few biogas plants. Instead, we are having a lot of investors going in, and you might have seen that the biggest Danish biogas company, Nature Energy, was bought by Shell 2 weeks ago, and the price is told to be 1.9 billion euros. So now we are not only the local biogas producers, but it's a huge industry. And of course, then we have a lot of farmers having their own biogas plants, or where they have the biogas plant and other investors had put money into their biogas plants. We normally use the digestate directly with these nose hustles to spread the liquid slurry. But what is happening right now with the increased use of straw, then we are facing a situation where the dry matter content in the digestate is also increasing. And this means that we simply need to look into separation. It's only a few plants that separate the digestate right now into a liquid fraction that will be used in the local by the local farmers, and a fiber fraction that can be used as a phosphorus fertilizer, or a soil restoration carbon-rich product, or it could go into pyrolysis to produce biochar in the future. But I guess we will see more separation plants. But this is important because we are very much looking into the carbon contents in the soil, and of course the farmers knows that if they grow cereals year by year, and especially if they deliver the straw to the incineration plants, then the carbon content in the soil will slowly decrease. Here is a very important slide from the University of Southern Denmark, where they have calculated on the incorporation of carbon into the soil, either if the straw is incorporated directly, this is the blue line, but what happens in the soil is that most of it will be degraded and turned into CO2 within a very few years. If we take the straw and put into the digesters, then of course the carbon that turns into methane or CO2 cannot come back as carbon, as fibers to the soil, but it's the easily degradable part that will be digested in the biogas plants. And when they calculate, then they conclude that in the longer term, we can have the same incorporation of carbon into the soil if we take the straw, put it into the digesters, as if we had incorporated the straw directly into the soil. And of course, if the straw was incinerated, then there will be no incorporation of carbon into the soil. So simply to conclude, I guess the main reason why we have had the success in the Danish biogas sector is that we have been very much focusing in where are there some problems or some challenges for the society where we could deliver the solutions, both in regard to reduce the leaching of nitrates from agriculture, the need to recirculate nutrients, a way to reduce the greenhouse gas emissions, both from agriculture and from the energy sector, and of course a way to have a shift from fossil fuels into renewable energy supply. And as you can see on the right hand side, we see the biogas as a key solution in many sectors. This was my final slide. Thank you.
No. Sorry. Thank you very much, Bruno. That was very interesting. There's been massive advancements from over those years, and I'll bring in our panel in a second, but just a couple of questions beforehand. First of all, just in terms of your standard Danish dairy farmer, and you've about 30% at the moment of your slurry going to digesters, that's looking to move to 2/3 in the next number of years, which is huge volumes. What is the general experience there? How does a dairy farmer get involved? Who does the transport? What do they get back? Is there what financially in that transaction? What happens? Or could you just explain how that works on the ground?
Yes, if we go back in time, then the local farmers would either invest in their own biogas plant or go together in a cooperative and establish a biogas plant. Most of the livestock manure is digested in what we call centralized biogas plants, and here the system simply is that a biogas plant has a lorry picking up the raw manure on the farms, bringing it to the biogas plant. But the lorry is filled 2 ways, so they deliver back the digestate to the farmer and then pick up the raw manure. And the driving force for many years for the farmers was that they had the logistics to redistribute livestock manure. If they had more manure than they could spread on their own land, then they got simply the logistics. And at the same time, they experienced that the yield was increased. They simply had a better fertilizer when it's being digested. In the recent years, when they can see that the biogas is an industry, and especially when we get into the biomethane, where the investors are allowed to earn money, then of course the farmers also want to have a share of that. But then again, it's important to look into the how will they get the value out of the biogas, and what are the different advantages the farmers need. So what we have seen is that when they draw up the contracts between the farmers and the biogas plants, then they are very complicated with a lot of issues to regulate the payment. We used to have, or this was introduced many years ago, was an incentive to make sure that the farmers delivered slurry with as much dry matter as possible. So there was a payment scheme. If they delivered average slurry, then there was no payment. But if it was thinner, then they had to pay. And if they delivered with higher dry matter content, then they could get a payment.
Do farmers do any pre-separation of slurry on site beforehand?
No, we had one plant that started up with the separation on the plant to only deliver the dry content.
Dry matter, yeah.
But the conclusion is that you still have to add some liquid on the biogas plants to make the solid fraction of the livestock manure pumpable. So you had to add water. And then the cheapest water you could get is actually the water from the livestock manure, and it costs the same to drive with an empty lorry as with a filled lorry. So the farmers don't separate on the farm, but and again, because of the economy of scale, if we need to separate to change the balance between nitrogen and phosphorus, then it's cheaper to do that on the biogas plant rather than on the farm. Yeah.
And just in terms of that, in terms of disease control, does everything have to be pasteurized then?
Not the manure.
Okay.
But anything else, the organic waste have to be pasteurized.
So you could have a communal plant with a slurry coming in from a number of farms, but no, that doesn't have to be pasteurized.
No, but still, if we're having the most of the biogas plants now are thermophilic, with a process temperature of above 50 degrees centigrade.
That's quite interesting, actually.
And this means that there will be pasteurization within the plants.
Did they change over to thermophilic because they were trying to increase capacity, or is it just technically works better?
They got the experience that it's possible to handle in the thermophilic process. The challenge is that they are a bit more you have to be more careful if you get too much nitrogen into the
Yes.
into the thermophilic. But at the same time, you can reduce the retention time in the biogas plants with higher temperatures. So the gas will be picked up.
And just a final question from me before I open up our panel here as well. Just in terms of the subsidy, it was interesting to see the figures that are being used there. You were on, but 15 euros per gigajoule, which we're working in megawatt hours a lot of time here, so it's about approximately 56 euros per megawatt hour. Is there a capital subsidy as well, capex, or is that all borne by the investment?
We used to have 30
Yes.
years ago. We had investment grants when we had to struggle with the developing the technology, the technological risk. There we had the investment grants, and then we had also the investment grants from 2009 until 2014. But this was due to the financial crisis, because it was very difficult for the biogas plants to get them financed. So in the short time we have the capex investments.
But in general now, it's not capex. It's purely on the gas. Okay.
Yeah.
And just for bringing the panel on a second, but just on in terms of, you put up some figures there. Say you're at 6. You started off at 6 petajoules in 2015. Well, you started off a long time before that, but in the last 7 years you're at 26 petajoules. Just to put that into context for our viewers, that's about 7 terawatt hours. We have a national target here, Bruno, was 1.6 terawatt hours. That's moved now to 5.6 to look at that by 2030, which is a massive target. But just to put that 5.6 is, you're at 7 at the moment, and it just puts it into context for us here as well to see what level of investment will be required. Sean, I might bring our CEO Sean Finan in also, and Barry Casland, Biogas specialist in renewable energy and rural development. You're welcome, Sean. Barry.
Thank you, and all.
So just in terms of, Barry, I might start off with you there in terms of where you would see, having listened to that conversation, where would you see the journey going for biogas here in Ireland, or how do we get to that level of development?
Yeah, we're very envious, Noel, aren't we, listening to that story about, where we are, where we currently are and where we should be. And I suppose there's been many false dawns in this area over the last number of years. We had expected that the industry would be at a much higher level of output at this stage, but we haven't really gone very far. A lot of false dawns, and as you said, the target there was set in the climate action plan there of 1.6 terawatt hours of biomethane by 2030. That would have required about maybe 80 farm scale AD plants, of 20 gigawatt hour in gas output. And they would have been using around maybe 30,000 tons of slurry and biomass on an annual basis. But this target then was increased by Minister Ryan to 5.7 terawatt hours by 2030, only in July of this year. So that's over a 250% increase in the target. So it's a bit of a tall ask, and that would maybe satisfy about 10% of our current natural gas demand. And it would require in the region of around maybe 200 AD plants, or maybe even more, at that scale of 20 gigawatt hours. So
it's quite a high target to achieve in that space of time, would you say? Yeah,
it's a high target to achieve, and I suppose it's going to require funding essentially for it to happen. And we heard about all the funding mechanisms that are available in Denmark. The renewable heat obligation seems to be our funding mechanism in our journey of travel. I thought we were going to go down a CHP route a number of years ago. The journey of travel certainly is biomethane, and because there's pressure on gas networks right across Europe to decarbonize the gas network, and this is the only way of getting a renewable gas into the system.
Can I just bring Bruno into that for a second? Bruno, is all the end destination for gas now, if you're going building a plant, is it all gas injection, or are we looking at anything external to that, or is it just everyone is looking at injection onto the grid?
Yeah, the support schemes in Denmark are only heading for the injection into the gas grid, but of course there's also other ways of using biogas. One of them is to liquefy the biomethane and bring it on lorries to consumers in other countries, especially for the transportation sector.
Okay, and Barry, just to go back to there on terms of you've a plant commissioning or due to commission in Teagasc that you've built in Grange. Do you want to update us on that, or where is that as a demonstration?
Yeah, the Grange plant is, I suppose initially it was planned to be a CHP, combined heat and power plant, but it's now going down the route of biomethane. Now, I don't know when exactly it is going to be fully commissioned, but it's I believe early in the new year, and it's supposed to have a biogas output of around 70 cubic meters per hour. So if you compare that, most commercial AD plants require about 200 cubic meters of biogas per hour. So they'd be 10 gigawatt hour plants to be economically viable.
Yeah.
So
well, would that be more of a research-based project?
Yeah.
In terms of that'll be something we can all we can use, not to say use it to downgrade the idea of it, but we can play with that and use it to develop our own technology or develop our own knowledge. Is that really the focus? It's not a commercial requirement.
Yeah, exactly. Most European biomethane plants would be 200 cubic meters per hour. This is a research plant. It's for demonstration for groups to see how AD works. It'll probably have an operational time of around 8,000 hours per year. It'll produce in the region of maybe, it'll be using grass silage, and it'll be using slurry as a feedstock. So in the winter time, it'll be using more grass silage. It'll be using maybe around 21 tons of slurry per day in the winter time, and it'll be using grass silage maybe around 10 tons per day. In the summertime, it'll be using around 14 tons per day of slurry, and then the grass will be maybe 2 tons per day.
Okay, and Sean, if I might bring in there in terms of the scale of plants we're looking at, we're seeing 2 different models coming out here in Ireland that we would see it. Would you like to explain that in terms of where we see the industry going?
Yes, thanks very much, Noel. Really, during the course of our own work, we noticed that there's a lot of confusion out there amongst farmers and the wider stakeholders excuse me, about the scales that are possible. So really, biogas production is possible at all scales. So at quite a small scale, from the point of view of an individual farmer wanting to decarbonize their own energy use on farm, to the medium to large scale opportunity, which would require maybe multiple farms to feed feedstock into a centrally located plant. So the differences are there. It's potential at all scales. There is some regulation which is driving that in Ireland. The animal byproducts regulations determine the particular requirements around each plant at each scale. So some will require pasteurization depending on the feedstocks, and then it depends on the size, whether that's economically viable or not at certain scales and certain levels. Also, in our opinion, from an Irish Bioenergy Association perspective, the support requirements are completely different from an individual farmer who would build a facility on their farm to the medium to large scale facility. So an individual farmer would probably prefer the most favorable support in that case would be a capital grant to offset the initial cost of the development, and then the return on investment would be secured through the offset of the fossil fuel bill. But then at a medium to large scale, really it's some level of support, of ongoing operational support in the form of paid per unit of output. So that could be in the form of a tariff or an obligation. But it's interesting to note in Denmark, that they're now engaging in their next round of support, and it is based on an auction tender system. And that would be very similar to what's happening here in Ireland from the point of view of our renewable electricity support scheme. That is an auction-based system. And you would be led to believe, when you listen to all the discourse in Ireland about renewable electricity, and we are at over 40% renewable electricity at the moment on the grid, that it hasn't received support over a long period of time, which isn't correct. It has received support. So if we want to develop a biomethane industry in Ireland, it is very clear a plan needs to be put in place by Minister Ryan and his department, and indeed working with other government departments, for some level of operational ongoing support in the form of an auction system, in the form of an obligation, a meaningful obligation that will reduce which will improve the economics of the facilities, and from there the industry will develop. But without that, it's hard to see how that 5.7 terawatt hour target will be achieved without some decent, meaningful level of operational support. which is the case right across Europe in all other European countries, that is in place and that has been supported. And we have seen increases in fossil gas prices, and the tendering auction system allows for that to be inbuilt into it, where the price of the fossil gas, if it goes above, or the price of gas on the grid, if it goes above a certain price, and that's higher than your tender price, then you don't get any support. Whereas if it falls, it gives certainty to the investor, it gives certainty to everyone in terms of paying for feedstocks. If it falls below that level, then you get obviously some level of support to make up the difference.
It's a guaranteed bankable price that you can work with.
So that's my feedback. Noel, thank you.
Yeah, and just one thing that comes to mind as you're speaking there, and it's a question for Bruno. You mentioned obviously all the gas is going on the grid, and we're seeing obviously across Europe an issue of security of supply, and we have, like, Denmark is a world leader also in wind energy. We have a lot of wind coming onto our system, but what we're very rapidly discovering is that dispatchability is a major issue, and where we need that solid backup power supply. Like we've had in Ireland for the last 2 weeks, we've had very little wind, so we're totally reliant on gas at the moment. Is that conversation gone anywhere in Denmark? I would assume it probably. I know you've much better connection to Europe, which helps along the way, but in terms of the gas being a base load power, even if it's going onto the grid first, it can be used in your larger power stations then.
Yes, we are having the discussion, and of course we are also in Denmark having the discussion of the risk of not having power in the system for a few hours. But what we see is that the value of a biogas is shifting from the base load to the backup, and of course here the gas grids and the storage facility is important. But what we also see is that many of the biogas plants that is right now upgrading the biogas, they are actually considering to install a CHP facility and have a bubble, a storage tank on the biogas plant, so that they can use some of the biogas in the hours with the highest prices and simply produce a lot of electricity here and sending the rest into the gas grid when it's possible. So somehow we have had this rapid shift from pure CHP to upgrading, and now it might be turning a little bit backwards, because what we have learned the last 10 months is that the energy systems are not always stable and guaranteed. We simply need to look into that.
Yeah, it's something we've all learned in terms of the flexibility, and there's no silver bullets. It's a case of having multiple uses for various feedstocks. Barry, one thing that came about there in the discussion, which I found very interesting, is Bruno, you outlined that 7,000 tons of phosphate that you're managing to recycle back into the agricultural system out of a total of 13,000 tons of phosphate usage. So it's a substantial part of the fertilizer requirement for the Danish farmer. Barry, I'm sure that is of interest to Irish farms. Sean, as well, that would be of huge interest to Irish agriculture.
Yeah, absolutely. I mean, look, the digesters there, like 85 to 90% of what you put into a digester will come back out again. It will have a lower dry matter. It'll have a high nitrogen availability. It'll have lower odor potential. And in terms of fertilizer prices today, like generally, if you took an average figure, maybe of 5.8 kilograms of nitrogen per ton, and maybe 1 kilogram of phosphorus per ton, maybe 1.5 kilograms of potash per ton. If you were to put a value on that, and also taking into account that the fertilizer or the nitrogen is in the ammonia form, which means it's more available to the growing plant, so you're working off of an availability figure of 100% as opposed to 40%, which would be with ordinary slurry. You could be talking in the region of a value there of the digestate. If you had a spreading rate of 21 tons of digestate per hectare, that would have a value of around 430 euros per hectare in that. You have to take the current nitrogen values of N, P, and K, the values of NP and K in terms of, you know, their price per kilo, and convert that across, you know, that's the value around 400.
There's huge scope there. Just, I'm conscious of a number of questions coming on the Q&A, and I didn't get to those yet, where our time is low. Just in terms of, you mentioned the phase down, Bruno, one question here, of energy crops for biogas. Again, I outlined at the start that we've seen a shift from Denmark to Germany in terms of who was seen as European leaders, but the German model is very crop-based, whereas and there's questions over that now, whereas the Danish model has always been waste materials, and a farm supports working within agriculture. So that phase down, what would be the reasons for that? Would you see, we have large amounts of grass silage here in Ireland? Should we be utilizing this? And I'll just link that with another question I see further down the stream, where the question is, Denmark is using a lot of straw as a feedstock. We don't have lots of straw here in Ireland, so should we be looking at grass? Or what would be your thoughts on that?
Yeah, the quick answer to the last is that of course you should utilize grass as a feedstock. The reason why we have this political view on the use of energy crops is it's mainly because 10 years ago, the Danish farmers in the southern part of Denmark started to grow a lot of maize to the German biogas plants, and the politicians simply wanted to send the signal that we don't want German conditions in Denmark. At that time, it was less than 0.5% of what went into the biogas plants that really was energy crops. It's also important to realize that energy crops, it's only 5 crops. It's maize and beet and cereals and grass and artichoke. And grass is not considered an energy crop if they are more than 5 years old. And then of course, with your permanent grasslands in Ireland, this would not be an energy crop in Denmark. But then again, you will have the discussion, I guess, on whether the farmers will be allowed to use fertilizers on that grassland to increase the production, or it will mainly be for biodiversity or some extensified production. I don't know whether that is in this discussion in Ireland, but it certainly is in Denmark.
Yes, there's also discussion related to that in terms of stocking rates and what's considered organic nitrogen and what's considered chemical nitrogen. I assume that's a discussion you're having, and also at the European level also, in terms of the nitrates directive.
Yes, of course, the nitrates directive sets the limits for the use of the organic nitrogen in all countries, and of course, again here the value for the farmers is that with an increased utilization, an increased ammonium content, then they will have a better utilization, and then they simply need to buy less chemical fertilizers. Yeah,
is it still considered, though, say 100% organic when you digest it coming out to the land? Is it considered an organic nitrogen?
Yes, it's still livestock manure. It's not. We are not having the end of livestock manure, but then you're having the opportunities now to look into the fertilizers regulation, and somehow start to turn it into sellable fertilizers. But the challenge is that the end of the life as an livestock manure is not clear.
Yeah. Just a question here, are you injecting both biogas and biomethane into the grid? So
no, biogas, the raw biogas, we have to clean it for the sulfur content mainly, and then they can be utilized in the CSP plants. To inject into the gas grid, we have to remove the CO2. This means we turn biogas into biomethane and then inject the biomethane.
And are you looking? Is it all? Does each individual plant have their own? And this comes back to another question there on scale. What is the general scale of plant and size of plant you see in Denmark? And are you seeing injection points? Like one plant will have one injection point, or are you looking at centralized injection, which we are considering here in Ireland?
Yeah. We are having more than 50 upgrading biogas plants, and all of them have their own injection point. And the scale is from less than 4 million cubic meters of biomethane per year up to the largest is close to 50 million cubic meters.
Gotcha. Okay. And I just see one question in there. So policy-wise, do you think it appropriate for governments to prescribe certain models of design, such an approach could be coordinated to permit development rights? Now, just trying to get the gist of this question, so that you wouldn't need detailed planning permission. So you have a sort of centralized model. We could say, I want to build a type 3 plant or type 4 plant. You could have tailored grant aid regime, so that effectively you would have a planning system whereby we would have already pre-designed plants. And you could say, well, I want to build what we term as a standard, I don't know, 1 megawatt plant, and it's all of it is. Is that something you've looked at in Denmark, that you would have a standardized system for planning? Or how do planners handle digesters in Denmark?
Then you start from scratch every time you want to consider to construct a biogas plant. It's simply the system that you have to make the assessments whether there will be an impact on the local environment. But of course, from an economic point of view, it's obvious that if you're not starting from scratch on each biogas plant to make the drawings, then you can reduce the cost. So from a building perspective, it's better to have some kind of a basic design you can scale. Okay. But you cannot. Of course, there's the difference on the size. Small biogas plants made on established on farms are having one set of rules, and larger biogas plants have another set of rules for the environmental.
And we've seen a lot of individual farms having their own plant.
Yeah, we're having more than 50 is owned by farmers. Yeah.
Okay. And I see one question coming in there in terms of, are you having any environmental issues dealing with ammonia?
Oh yes, we have, again, European Union set a target that we should reduce ammonia. There was a target in 2020 and another target in 2030. In Denmark, agriculture has to reduce with 24%. And that target was in 2020 and the same target in 2030. So we are taking it in one step. And here, of course, the challenge is that when we digest the slurry, then we will increase the pH value, and this means an increased risk of evaporation of ammonia. We used to say that at the same time, we turn the livestock manure into a thinner liquid that disperses quickly into the soil, and those two will balance. So there's not an increased risk of evaporation of ammonia. But again, here the challenge is that when we add a lot of deep litter and a lot of straw, and the dry matter content might increase in the digestate, then there's a risk that the digestate will stay on top of the soil when it's not being injected into the soil.
Yes,
injection is one solution, but we cannot do that in all crops. And that's the reason why I say that we will look into separation of the digestate, or at least longer retention time in the digesters to make sure that we get as low a dry matter content as possible.
Okay.
But ammonia is an issue. Yes.
Yes, and it's well, look, thanks very much for that. It's been very interesting to see the level of development in Denmark. You're confident of reaching the 90 petajoules, are you?
No, we are confident that we will reach 60 petajoules. I will retire when we reach 60 petajoules.
Okay. Very good. Bruno, thanks very much for today. It's been very insightful to see, and it's something that's a model that we would like to see worked on in Ireland. We've a long way to go, as Barry's lined out earlier on. We thought we would be far further on in Ireland than we are today. We're not, and there's a lot of work to do, but definitely the Danish example has been is spectacular, and something we can fits in quite close to Irish agriculture. So it's something we would be interested in working closer with in the future. So thank you very much for your presentation and for joining us there this morning. Sean, thank you very much for joining us from Urbia, and Barry from Teagasc. And for all of our viewers there, we've gone over time and you have stayed with us, so thank you very much for that. and we will see you all in the new year. So if I can say, wish you all happy Christmas and a happy new year to you.
Same to you.
You know,
Yeah,
thank
bye.
you.
Yeah.